In After Effects, as with much video software, colors are defined by channels. If we look in the info panel here, we can see R, G, B, and A. R, G, and B are the three channels of RGB color, and A stands for alpha. If I position the mouse pointer over the composition panel, the info panel tells us the R, G, and B components of this color. If I put the pointer over an area that has quite a lot of red in it, then we see that the red value is relatively high. And if I put it over an area that has quite a lot of blue and green in it, we see that B and G are relatively high. A is 1.0 across this image because transparency is 0 and opacity is full. You can choose to view color information in a variety of formats. If you go to the panel menu in the info panel, you can choose between decimal, which is what I currently have, or integer ranges for each of the common color bit depths, 8 BPC or bits per channel, 10 BPC or 16 BPC. I'll choose 8 BPC, and here notice that when I position the mouse pointer over an area of the composition panel, the color values are all between 0 and 255. 255 represents pure white or pure saturated color, and 0 represents black. In the decimal scheme, it was 0 representing black and 1.0 representing pure saturated color. We can also choose HSB, web, which uses a hexadecimal type of display. I'll select that. And you can see the alphanumeric characters there. Percent or autocolor display, where autocolor display picks the right format for whatever the color bit depth of the project is. I tend to think in decimal, so I leave mine set to decimal at all times. You can set the color bit depth for a project in a couple of ways. The easiest is to Alt-click or Option-click on the bits per channel indicator in the project panel. If I Alt-click once, it goes to 16 BPC from 8 BPC. If I Alt-click again, it's now 32 BPC, and once again, back to 8 BPC, Alt-clicking. The term bits per channel refers to the fact that After Effects uses a certain number of bits to store color information in each channel. When you have 8 bits per channel chosen, After Effects uses 8 bits for the red channel, 8 bits for the green channel, 8 bits for the blue channel, and the same is true for alpha. That's a total of 24 bits for color, or if you include alpha, 32 bits for the entire pixel. If you have 16 BPC chosen, then that's 16 bits for each of the color channels, for a total of 64 bits for a pixel. If you have 32 bits per channel chosen, that's a total of 128 bits for an entire pixel of R, G, B, and A data. The more bits you use to represent a pixel's color, the more precise the color can be. But also, the larger the data, and therefore, the slower the processing in many cases. There's another way to choose the project's color bit depth settings, and that's to click this value instead of Alt-clicking it. That opens the project settings dialog box, and you can choose depth here. 8 bits per channel, 16 bits per channel, and 32 bits per channel. Notice that the word float is next to 32 bits per channel. That's because 8 bits per channel and 16 bits per channel use integer representations, but 32 bits per channel uses a floating point number, meaning that the number is represented with a decimal point that can float back and forth through the number as appropriate. This technical detail isn't really important, but because some people use the term float to be synonymous with 32 bits per channel, it's good to know. In After Effects, 32-bit per channel color is also high dynamic range color, meaning that when you have the project set to 32 bits per channel, the color values can go below 0 and above 1. This means that colors that are darker than black or brighter than white can be represented. You can't see colors that are darker than black or brighter than white on a computer monitor, but being able to store and represent these values is very important for many compositing and effects operations, as we'll see. I'll choose 32 bits per channel and click OK. And now, as I position the mouse pointer in the composition panel in this really bright area, look at the info panel. The color values all are greater than 1.0, meaning that the color here is actually brighter than white. You can't see a difference between this brighter than white and simply white, but After Effects knows that this area is even brighter than a white area. Let's see how that can be useful. If we would like to decrease the exposure on this image to bring down the brightness and bring out some of the detail in this blown out area, we can go to the Effects and Presets panel, type Exposure, find the exposure effect in the color correction category and drag that onto our footage layer. And then decrease the exposure. I'll bring it down by -1. And then notice we get a lot more detail brought out of this blown out area. I'll turn the effect off, then back on again, then off, then on again, so that you can see that big difference. Now, this is because After Effects knew that even though this area was blown out white, there were differences in the brightness values, so that when the exposure brought the brightness down throughout the image, it knew that this area should be darker than this area. If we go to the project settings and change this to 8 bits per channel by alt-clicking, notice that in 8 bits per channel, the result of bringing down the exposure is just a washed out mess. Same thing at 16 bits per channel. And now, going back to 32 bits per channel, pay attention to the difference. So, the benefits of 32 bits per channel color is not just higher precision, but also the ability to store overbright values, which can then be used for later compositing and effect operations. But you don't always need 32 bits per channel. Sometimes 16 bits per channel is enough. For example, if all that you're doing is trying to avoid banding and gradients, 16 bits per channel can often be adequate. Let's see how this works. Let's go to the Hip Hop Girl composition, and let's create a gradient behind this woman. I'll use the ramp effect to create a ramp or a gradient behind her. With the composition active, I'll create a new solid, layer, new, solid, click OK, drag that layer underneath, and then apply the ramp effect to it by dragging the ramp effect onto the layer. And I'll make the ramp start at 50% gray, so that's 0.5 in our decimal scale for each of these values. Click OK. And now, for the end color, I'll use something that's only very slightly different. 0.55, 0.55, and 0.55. Click OK. Now notice, as I drag from the bottom to the top in the composition panel, how the numbers in the info panel change. They're changing by very small increments. Now notice, if I switch the project to 8 bits per channel, alt-click on the BPC value. Now, as I drag from the bottom to the top, the values in the info panel aren't changing nearly as often, and they're changing by larger increments. We can't really see the result here because we still have relatively small changes in color, but we can introduce banding by using something like a brightness contrast effect. Now, if I increase the contrast, we get a very stair-steppy look in a gradient, which is not what we want at all. If I go to the project settings again and alt-click the 8 BPC number to move it to 16 BPC, the stair-stepping goes away, and we have a nice smooth gradient. 32 BPC would also make the stair-stepping go away, but it's overkill for this particular purpose. So, if all that you need to do is remove banding or stair-stepping and gradients, consider working in 16 BPC instead of 32 BPC. A word of warning, you probably don't want to work in 32 bits per channel at some times during a project and then switch back and forth between that color bit depth and one of the lower color bit depths. This is because blending modes and various other color operations are different with high dynamic range color, and so the visual results will be different. On the other hand, switching back and forth between 8 bits per channel and 16 bits per channel doesn't introduce any of these problems. So, even if you're using 16 BPC to get rid of gradients, as we just did here, you might want to work at 8 bits per channel a lot of the time just because it's considerably faster, and then switch to 16 BPC later for final preview and then final output. So, as you can see, each color bit depth has its own purpose, and you can choose to show colors in whatever format suits you best.